Hi, my name is Michaela, and in this video I'm going to be taking you through how I installed a Volvo electric power steering pump in my drift car, and also how I made an Arduino-based controller for that power steering pump. So before jumping into the details here, I wanted to give a little bit of context for why I decided to go this route. I have a Catfish Camaro as my drift car, which even though it's a pretty out there choice for your first drift car, it's been really good to me. The only thing I've ever really had issues with for almost 2 years of drifting it now is the power steering system. Every couple of events, it would start sounding like a supercharger and leaking everywhere, and I decided that after the last one started making noises, I needed to try something a little bit different. I was a little bit tired of doing this all the time. I am going to have this video split into two parts. The first part is going to be talking all about the actual install here and how you go about doing that. So that's going to include an overview of the two different ways you can set up the Volvo power steering pump, everything you need to make the controller happen, including the code. I'm not going to go too deep into the code, but I'll have it linked in the description for you to download. We're going to talk about all the wiring you need to do. I have files you can download for the prototype 3D printed enclosure that I made, and it will just have everything I think you need to know to do this install. And then the second part of this video is going to be essentially me trying to prove to you that this works for a grassroots seat time car like this. So I'll have some video footage from the last Spirit Peaks event I went to of me drifting my Camaro, and hopefully that'll be enough to convince you that this is a good alternative to the GM power steering pump I was using. Now we're ready to look at the overall setup for installing one of these pumps into your car. And for that I made this diagram, which you can see here. I'm going to go ahead and put in the description a link to where you can download this image if you want to use it as a reference. I tried to put as much information as I could that'd be useful in there, and all the parts that are referenced on this diagram are going to be listed in the document I'll have in the description that lists off where I bought all of this stuff, so you can use the same exact things if you feel like it, or at least know exactly what I'm talking about here. So looking at this, I have this split up into the wiring on the top, then on the bottom is the actual plumbing for the power steering fluid. So there are two different ways you can install your Volvo power steering pump. The most simple is going to ignore the two CAN bus wires that you see up there, so you won't have a controller in that case. You won't have those two wires. You will still have the 12 volt to turn the pump on. And what is going to happen is when the pump sees 12 volts, it'll still turn on the pump, but it'll see that it's not getting any CAN bus signal, so it's going to go into a backup mode and run in that backup mode for you. And that mode is going to have it running at somewhere between 50 and 70% of the pump's full power. I did actually have this set up this way on my car for a couple of weeks and drove it around on the street that way. And I found that if you're just looking for a power steering system for your cruiser or your drag car or something like that, it's perfectly adequate. I had no issues in parking lots or any of the street driving I was doing. The only places I would run into issues were when I was trying to do some pretty intense steering inputs from side to side right after each other. So say I'm driving on the road and I turn hard to the left and turn hard to the right and try to turn hard to the left again, then on that last action you can feel the pump struggling to keep up a little bit. You can feel a barrier in the power steering there. So if you have a drift car where that's going to happen in your transitions, or you have an autocross car or something like that, then this setup is probably not ideal for you. Road racing guys, I think it kind of depends. I mean, you don't really go back and forth that quickly on big tracks from what I've seen as much, but that would kind of be up to you at that point. So the alternative here is using the CAN bus wires you see in the diagram here to send CAN bus signals to the pump, and this will allow us to control the speed at which the pump is running, so we can set it to run at 100% of its power all the time, which I found to be pretty good for drifting. That's at least what I was using at this last event. But to do this, we're obviously going to need a controller of some kind to actually send those signals to the pump, right? So that's where we're going to use the combination of an Arduino board and a CAN bus board, and those two will work together to send those signals to the pump and tell it, hey, I want you to run at, well, in our setup we can tell it to run at whatever power we want. We can tell it to run at the very lowest it can go, all the way up to 100% power, and everything in between. On the bottom half of this diagram, you can see some information about what I used to plumb my Volvo power steering pump to my steering rack. Now on the steering rack side, for those fittings, you're going to have to look up what you need for your specific steering rack. But on the Volvo pump side, you should just need either an M16 or an M14 to -6 converter. Make sure you measure when you get your pump. I've heard online that sometimes those are M14. Mine was M16, so that's something where you'll want to double check that with the pump you get. And then once you have it converted to -6, you'll want to pick up a power steering rated hose for your high pressure side. This hose can see up to 1000 psi of pressure, so you want to make sure you get something that's advertised to withstand that. Just using normal AN lines probably won't work for very long. But then on your return line, you can use just any power steering return line. That should be fine. And I went ahead and put a cooler in line with the return. Not 100% sure if that's necessary, but it seems like a good idea for a drift car. For this project, you're mainly going to be using 20 and 6 gauge wire. The 6 gauge wire is for the power and ground to your pump, and then the 20 gauge is basically for everything else. That's going to be your 12-volt signal wire, your CAN bus signal wires, all the wires that go into your Arduino controller. I use 20 gauge for all of that, so I would recommend stocking up on some of that. I get all of my wire at this point from a site called McMaster Car. And I've also really been a fan of the fiberglass sleeving that McMaster has for different gauges of wires. It's probably a little overkill for a lot of the places where I used it, but I like the peace of mind knowing that if I have an overheating issue or I have something that's starting to rub against something else for my wiring, that stuff should be pretty okay. Now let's talk about what we are going to need to make our controller. So we are actually going to need 2 different boards for this. The first will be some kind of Arduino. I used an Arduino Uno when I was testing this out, and then I switched to an Arduino Nano Every for the final product, just because it has a smaller form factor. But really, any Arduino should work as long as you have enough I/O capability to be able to connect everything together that you need to connect, which I'll put up a diagram in a second showing exactly what you need to connect to what. But the other board you're going to need is an MCP2515 CAN controller board. Now these are really cheap and easy to come by. Here is just a quick search on Amazon. As you can see, you can get 3 or 6 of them for almost nothing. And then you'll also want to get a potentiometer so that you can give your controller input for what speed you want it to run at. My boyfriend had like 50 of these lying around, so I just stole one of his, but this should be another thing that should be very easy and cheap to come by. Now we're ready to start talking about actually wiring up our controller, so wiring our 2 boards together. Now in a lot of cases when you buy an Arduino, it'll come with header pins already soldered onto the board. I would actually recommend finding a Arduino board that does not have that already soldered together, because what I would recommend doing is sticking your wires into the holes where the header pins go and just soldering directly onto there. Now what you'll see a lot in Arduino projects is people will just use jumper wires, which is a good strategy for prototyping and making sure that your setup works. But I would suggest against using that, especially in something like a drift car, because I would just be very concerned about something shaking loose there eventually. So when you have everything soldered on, that should be a much more solid connection. But before we start soldering anything together, we need to know what our connections need to be here. We need to know what pins from one board should be connected to pins from the other board. And luckily this information is pretty easy to find online. Here I have a diagram with a table showing which pins go to which pins on both of the boards. So all you need to do is look at the pins on your respective boards. They should be labeled on there, and then just make sure you have the wires connecting the right pins. So at this point I'm assuming that you have your 2 boards wired together, so now we're ready to actually upload the code that I have to the Arduino board so that it'll hopefully work as we want it to as our CAN bus controller. So to do that, you're going to connect your Arduino board to your computer via USB. You'll have to install the Arduino IDE if you don't already have it, and then you're going to upload the code that I have linked in the description onto your board. So at this point I'm not going to go through the step-by-step process of how you do all of that. I'm going to assume that that's going to be pretty easy to find online. But if you guys do have trouble with it, feel free to let me know in the comments, and I can totally make another video going through the step-by-step of how to install that and set up your Arduino, as well as maybe going through the code a little bit if anyone's interested in that. There are two things you should double check though before moving on to the next step. The first being that both of the lights on both of your boards come on. So the light on your Arduino should come on from the USB power from the computer, and then if you have all your wires connected correctly, the light on the MCP2515 board should also come on. So you want to make sure you have two lights for your two boards. And then you also want to take a look at the output you get in the Arduino IDE when you upload your code to your Arduino. So you're going to want to open the serial monitor, and a little pop-up like this will open. You might see a symbol like this, which means you'll have to change your baud rate. So just double check in the code here. I have in line 85, it says what baud rate you should be using, so make sure that lines up with what your serial monitor is looking for, otherwise it's not going to be able to interpret what it's seeing. So once you do that, in this case I unplugged and replugged in my board to restart it, and then once it does that you should see setup complete come up. Last thing you want to double check in the code before moving on. So we have this line 89 here, which tells it what frequency the crystal on our CAN bus board is running at. That's going to be this part right here where it says 8 megahertz. So you're going to want to double check on the listing for the board that you bought what kind of crystal it has. In my case, for the Amazon purchase I made, I had to look in the reviews to find that, but people will usually tell you in the reviews at least, even if it's not listed in the specifications, what kind of crystal you have on your board. Commonly they're going to be 8 or 16, so if you happen to have a 16 one, you really need to change this to 16, otherwise this isn't going to work. Now I have a couple more wiring things to address before installing this in our car. Your CAN bus board should come with a terminating resistor built in, so you're just going to want to connect the two pins for that together so that that works. And in this case on my board, they have J1 written next to them and are right next to the CAN bus signal wires. So my recommendation will be to just use some solder to connect those two pins together. In this case I have jumper wires because this is my prototype board. Now we need to wire in a potentiometer so that we can tell our controller what speed we want our pump running at. And this is going to be very simple. So your potentiometer should have 3 prongs coming off of it. The 2 outside ones you have to connect to ground and then to 5 volts. It doesn't matter which side is which. It's just going to affect the direction that your potentiometer is going to turn in to have different effects for increasing the speed or decreasing the speed. And then the middle prong you're going to want to connect to pin A0 on your Arduino board. That's going to be the first analog input pin. You can always use different ones, you'll just have to change line 64 in the code to line up with whichever pin you use. Then the last piece of the puzzle is taking our car's electrical system, which is going to be 12 volt usually, and taking it down to 5 volts, which is what the Arduino wants. So to do that, I just bought a cheap converter off of Amazon. It seems to be working reasonably well. It's pretty simple. You just hook it up to ground on both sides, and then you hook one side up to your 12 volt from your car from somewhere, and then it should put out 5 volts on the other side, and it's nicely labeled, so it should be pretty straightforward. Now we should be ready to start thinking about actually putting this in our car. So one of the first things you want to think about is running the 3 wires you're going to need all the way from the pump to wherever your controller is going to live, probably on the interior of the car somewhere, right? So these are going to be some pretty long wires that you're going to want to route in a way that makes sense in your engine bay, so maybe not right next to your exhaust or things like that. As you can see, I used a lot of this fiberglass sleeving. Might not be 100% necessary everywhere that I used it, but it was fairly cheap, so I figured I might as well. And just as a refresher, those 3 wires are going to be a 12 volt signal wire that should be on a switch somewhere in the car, and your 2 CAN signal wires, so CAN high and CAN low. Once you have those wires run in a way that you're happy with, you want to connect your 2 CAN signal wires to your MCP2515 board. There is a labeled spot for both of these. It says H and L on it. You can either use the provided screw-in connections, or you can take out the header pins that are next to those and solder those wires on, which is what I did. You're going to want to refer to this diagram I made to know which wire goes where for the pump pigtail. So the gray and blue wire is going to be that 12 volt to turn on the pump. and then the other two are going to be your CAN signal wires. So the CAN high wire will be gray and red, and the CAN low should be blue and red. That should be all the wiring you have to do for your controller. So at this point you'll want to make sure you have your pump wired up, so you have your power and your ground for your pump, and then that should be it for the wiring for this project. So now we can start talking about the enclosure I made for my controller. This is very much just a prototype. I'm not very good at CAD at the moment, so this is the best I could come up with, but feel free to take what I have and make your own spin on it. The main thing I wanted was to have everything enclosed in one unit, and then to have the potentiometer easy to access in there, and have the voltage converter also hooked onto it as part of the package. The enclosure itself is 3D printed out of PETG. I'd highly recommend going with PETG over PLA because it's a bit more heat resistant. Here's an example from my WRX of what will happen if you leave PLA sitting in a car for a couple of years, and it doesn't even get that hot here where I live, so I'd highly encourage PETG if you don't want it getting all melty after a while. To hold everything together, I ended up using plastic hardware. This was mainly due to the fact that a lot of these screws are extremely small. On the Arduino Nano Every, the holes to mount the board to something are very small, so that was kind of the limiting factor there. And so I went on McMaster and ordered these screws that you can see on the screen here for the Nano Every, and then these screws for the MCP board. So depending on what Arduino you use, you might have to use something slightly different. But then I went ahead and tapped these by hand because it's plastic, it's 3D printed, so that was fairly easy, and that worked pretty well. Then you're going to do the same thing on the four corners that hold the bottom plate to the top box part, and these are going to be the same screws that you used for the MCP board. Then you'll also want to tap the two holes on the side of the enclosure. Those are for the voltage converter, so you can just mount that right onto the side. And then the last part is going to be to take your potentiometer and screw that in using the nut on the other side. Then you'll want to make sure all your wires are routed out there nicely through the hole that's on the side before you close it all up, and then you can screw it together and it should be ready to throw in the car. For actually mounting the enclosure in your car, I came up with a solution to have these hooks that you can put a zip tie through, and then you can use the zip tie to kind of mount it wherever in the car. I'll be honest, I'm not super happy with how this came out, and at some point I want to redo this and come up with a different strategy for that, but it did seem to work, so that's good enough for me for now. So here's a video demonstrating the behavior you should see from your controller once you've done all this and hopefully everything is working correctly. So you flip the switch first, and that will kick on the pump, and then you should be able to turn the potentiometer on the controller and audibly hear a difference in the pump speed. There's one last caveat I wanted to bring up, and that is your power steering rack. So your rack's going to be different depending on what car you have, and it seems to work quite well in mine, but I know that Taylor Ray tried putting one of these in his Miata, and even though I didn't have the controller, in my experience my car felt just fine, even just at the backup mode, and he was saying his felt very strange and not right at all. So I'm wondering if that is because of the Miata rack being different from the Camaro rack, and that's something that I honestly don't know enough about to really speak to, so make sure you do some research on that and treat this as kind of an experimental project if you're going for this in a car where this hasn't been done before. This wraps up the how-to for making your CAN bus controller for your Volvo power steering pump. hopefully this worked well for everyone and you guys found this useful. Feel free to leave me some comments if this didn't work or you're having problems or anything like that. And kind of in the same vein, this is my first YouTube video ever, so if you have any constructive feedback, feel free to leave it for me. I already have a lot of things I want to do different going forward, but as long as you're not too mean about it, I'd love to hear what you guys think. So to wrap up this video, I have some footage of me drifting the Camaro with the Volvo power steering pump and controller. I just want to give a big shout out to the drone pilots who were there and took this footage. It's really incredible, and I have all their Instagram accounts on the bottom of the screen, so check them out. And with that, thanks for watching, and hopefully I'll see you in a future video.